Hey guys, welcome to lesson 5, reference angles. So this is the last unit for our trig review lesson. So I want you to pause the video and try the warm-up. So the warm-up says find the exact value of the following. Whenever we say exact value, again, we will not put those values in the calculator unless they are quadrantal angles. So my sine of 270, I'm just going to zoom into each one of them. My sine of 270 is -1. So -1. Cosine of 45 is rad 2 over 2. And sine of 60 is rad 3 over 2. So that's what you're doing. Substituting the values first and then simplifying whatever you can. So multiply nothing cancels. So I'm going to multiply out all the numerators. So it'll be negative rad 6 over 4. You cannot cancel the 6 and the 4 because 6 is under the radical. So be very careful about that. Number 2, your angles are in radians. So what do? Convert it to degrees. So I'm just going to substitute pi with 180. 180 divided by 6 is what? 30. So cosine of 30 plus 3 cosine of 180 divided by 3 is 60 cosine of 60. So all I need to do is know my cosine values. So my exact value for cosine at 30 is rad 3 over 2 plus 3 times cosine of 60 is 1/2. So I'm just going to simplify this. This would be rad 3 over 2 plus 3 over 2, or I can say rad 3 plus 3, take the LCM over 2. Okay, the last one. 3 secant pi over 6. Again, change your angles from radians to degrees. So I'm going to substitute it 180 over 6. So 3 secant 30 minus 30 degrees minus cotangent. 180 over 6 is again 30, right? So pi over 6 is 30. So 3 secant of 30 is what? 2 rad 3 over 3 minus cotangent of 30 is rad 3. So what happens here? The 3's cancel out. In multiplication, I can cancel something in the numerator with something in the denominator. So I'm left with 2 rad 3 minus, it's like 1 rad 3. Your radicands are same, so I just combine the coefficients. 2 minus 1 is 1 rad 3 or just rad 3. So that's my answer. So this is how you do these. That was your lesson 4. So let's get started with today's lesson. For every angle drawn in standard position, there's another angle called the reference angle. The reference angle is an acute angle. Acute means what? It's less than 90 degrees. Formed by the terminal side of the given angle and the x-axis. We talked about this in past 2. What is it saying is that no matter where my angle is, let's say if I'm in the first quadrant, actually my angle and my reference angle both are the same. Your reference angle is always between the x-axis and your terminal ray, right? So that's why my angle is here. So here are a few pictures, and before I go to the pictures, I just want to say one more thing. My reference triangles look like a butterfly, never an hourglass. So draw that picture please and cross it out. So look here. How do I find my reference angle? If I'm in the first quadrant, which I said your reference angle and your actual angle are the same. What if I'm in the second quadrant? You're going to do 180 minus theta. Let's say I'm going to quickly give you an example. Let's say this was 120 degrees. Your angle A was 120 degrees. So this would be what? 180 minus 20. So your reference angle is what? 60 degrees. Isn't that what I said? 180 minus theta. If you're in the third quadrant, it's going to be the angle minus 180. So let's say my angle was 225 degrees. So it's going to be 225 minus 180, which would be 45. So your reference angle would be 45 degrees. And last not least, we didn't talk. The first one I already did talk about. So the fourth scenario would be when your angle is in the fourth quadrant. So it would be what? You're going to do 360 minus the angles. So give me a number that's larger than 270 and less than 360. So let's say 300. let's do 300. Very basic, right? So 360 minus 300. So your reference angle is what? 60 degrees. So that's how you find your reference angles, okay? Depending on where you are. So we can use reference angles to rewrite any trigonometric expression as the function of a positive acute angle and find other angles that have same trigonometric values. So I'm going to be using an acronym QSFR. That's going to help you do these questions. What does that mean? Anytime you're given a question like that, right, to find an exact value of any number, that's you first find the quadrant. So it's going to be, this stands for quadrant. So let's write that down. Quadrant. S is going to be the sign. How do I determine the sign? Going back to your ASTC. All students take calculus. So all signs, all trig functions are positive in the first, sine and cosecant, CSC, are positive in the second, means all the other functions, all the other four are negative. When I say this, these are positive, means the other four are negative. Tangent and cotangent are positive in the third, meaning sine, cosecant, cosine, and secant are negative. And cosine and secant are positive in the fourth. Okay, so S stands for the sign, depending on what quadrant did you end in. F is for the function. What function you're working with. So we can work with our, and what's your reference angle? Remember, your reference angle is an angle which is less than 90. Always less than 90 degrees. Okay, so based on these, we're going to start working with these questions. I'm going to do 2 examples and then I want you to finish the remaining packet. So it says find the exact value of cosine 210. Can't use the calculator, so what am I going to do? I'm going to write my QSFR. And I'm also going to draw a picture. I cannot do these questions without drawing pictures. Cosine 210, where would it be? Write down your angles, your quadrantal angles, I would say. 90, 180. Since it's a positive, so I'm not going to worry about my negative angles. Okay, so 210 is going to be where? It's greater than 180, less than 270, so I'm in the third quadrant. So that's my terminal ray. In the third quadrant. Now, I want to draw my reference. So let's do the quadrant is third. So in the third quadrant, let's do the sign also. Cosine is positive or negative? Cosine is negative. Let's write down our ASTC. Only tangent and cotangent are positive. It means the sign would be negative. What's the function? The function is cosine. Now I'm left with just my reference angle. So what do? I'm going to draw my reference triangle, right? And this is my angle theta. So this was what? 210. So how do I find this angle? It's 210 minus 180. So it will be what? 30 degrees. So what's your reference angle? 30 degrees. It's always going to be a number less than 90, right? So now what do? This helps me. So it's going to be, what is negative cosine of 30? Negative cosine of 30 degrees is same thing as cosine of 210, which is cosine of 30 is rad 3 over 2. So that's what we're trying to find, the exact value, negative rad 3 over 2. Number 2, it says express sine of this angle. I already know I have to convert it as a sine function of a positive acute angle. So it's not even asking me for the value. It just wants me to write it as a positive acute, means what? Less than 90 degrees. So they just need me to find the angle. So again, I'm going to sketch my axis and I'm going to find out, first of all, before I even do that, let's convert it into degrees. So basically I'm going to either multiply by 180 over pi or substitute pi with 180. So let's do that. Put that in the calculator or do some mental math. So 9 goes into 180 20 times. So 20 times 9 is 380 degrees. So going back here to a quadrant where it's 380 degrees. This is 0, 90, 180, 270, 360, and that would be what? 450. So your 380 is actually in the first quadrant. So that's your terminal ray. So I'm going to draw my reference triangle drop the perpendicular. Remember again, the reference triangle is between the x-axis and the terminal ray. So what is that angle? So this is 380. 380 minus 360 is 20. So I basically know the positive acute angle is what? Q. Let's write that down. FR. So I'm in the first quadrant. My sign is going to be what? Positive. Everything is positive. My function is what? Sine, and my reference angle is 20. So basically, I wrote it as a positive angle, sine of 20 degrees. But there's a catch. My answer was in radians. So I need to convert this into radians. So let's do this. 20 times, what do you do? Pi over 180. Whenever you're converting into radians, right? So what's 20 divided by 180? It is 9. So my sine of 20 is same thing as pi over 9 radians. So that would be my acceptable answer. I can't write it, leave it in degrees. It's not wrong. It's just that because since my angle was in radians, I should write my final answer in radians. So I want you to finish the remaining of the packet. Please make sure you use QSFR because it's going to really help you, and you draw pictures when you're doing these questions. And if you have any questions, reach out to your teacher.